So I'm going to talk all about future, little bit about present, but mainly about future. How we drive innovation, what technologies we are looking into for the future, I guess, for building technologies, how Siemens does innovation also. And then at the end of the day, or at the end of my session actually, I have a proposal for all of you that might be interesting for us to collaborate on. Maybe all of you, or maybe one of you. I hope somebody will say, yes, I will do this. And that would be really, really interesting. Again, my name is Osman Ahmed. I have my email address here. So if you have any questions, if you want to send me an email after our presentation, feel free to send me one, and I'll be happy to discuss more. Okay, great. So I chose this name a little bit intentionally. I said smart built environment, emerging technologies, and then I also said this is actually could be sustainable because they are synonymous. There is no difference between sustainable and smart and intelligent because the nature, as we all know, very, very intelligent, smart, perhaps more than we know. So maybe we'll be looking into that a little bit also today from the building industry or from the building perspective. How intelligent is nature and what we can learn from nature to make our buildings sustainable. So that would be interesting. Feel free to ask me any questions, by the way. So, we have plenty of time, hopefully, so we don't have to rush things. Okay, so what is Siemens innovation? So I'm basically looking at the innovation within the Siemens Corporation, this big company, roughly 400,000 people. I don't know how many billions of euros or dollars of revenue. So we spent yearly about 4.4 billion euro on R&D throughout the whole world. That is our R&D budget in a year. And although we are challenged every year, constrained every year fiscally and financially because of a lot of global events, things that we don't control, every year as our graph shows, this investment is actually increasing incrementally. Not that how much we like to have, but still it is increasing. We have 29,000 people. They are dedicated in R&D. They are not in the business. They are basically supporting business R&D essentially. And then we have about 8,600 patents worldwide, and we apply 4,300 patents globally yearly. That is kind of our focus also, that we want to have a very rich IP patent portfolio globally so we can compete and we can commercialize those IP portfolio. Then we have worldwide collaboration with universities, colleges throughout the whole world. At any given time, maybe we have 5,000 collaborative projects that we are doing globally, from China to India, from USA, of course, big time, Europe. All right, then we have, besides that 28,800 people, we have 7,800 people. They're essentially dedicated on research. So they're not doing any development. They're supporting businesses, yes, but they're mainly focused on research. Not fundamental research, but applied research. For example, how can we make a wind turbine more efficient, or how we can make buildings more efficient. So they are actually funneling their research results into this R&D organization so we can then actually commercialize these things. 1,600 of them are pure researchers. So we have physicists, we have chemists, we have biologists, by the way, within our company besides IT folks and focusing on emerging technologies. We have 400 patent lawyers globally. So their goal is to actually make sure that when we are inventing something, they can take our idea and then basically apply for patents. And then within this organization, we have 5,000 software developers. So their goal is to actually look at the research. So they're kind of bridging the gap between the researchers and the R&D folks in terms of software, what we have to develop. Well, we are one of the largest software developing companies in the world, believe me or not. So people don't realize that sometimes. Okay, all right. So what is driving our innovation? Of course, you, the customers and the business. So our innovation portfolio, the investment portfolio that we make every year, that is actually based on what we hear, what we learn from our customers, from the market, from people like you, and basically then that actually drives our innovation investment strategy, long-term, short-term, incremental, so on and so forth. So right now, just to give you an example, we are looking into few mega trends in the world. Globalization, urbanization, demographics, climate change. These are the big mega trends that is driving our company's strategy, business strategy that is, as well as our innovation strategy. So both, those mega trends, essentially we are constantly looking into new mega trends. We are looking into or assessing the current mega trends and asking ourselves that what solutions in the future will be supporting those trends that will come, let's say, 2020 or 2030 or 2040. So we have a very, very long-term vision, and that vision is actually driving us to ask ourselves what products we have today and what products have to be in the market tomorrow. All right, so this mega trend, one of the mega trends, this digitalization, is actually changing our business world. This is a big thing for us. So Siemens wants to be known in the world as one of the premier digital company, because we have the asset, the physical assets. I'm going to show you some examples, some numbers, and we are actually can access data from devices, from medical equipment, from X-ray machines, CT scan machines, buildings, of course, trains, railway, wind turbines throughout the whole world. So the question is how we can actually monetize that data that we can access for the betterment of our customers' solutions, basically, to increase their efficiency, to basically hit their top line and bottom line. We want to make sure that the data that we process is actually going to help you. So here are some numbers. What type of mega trends we see by worldwide? We will be actually looking into, for example, 40 zettabytes of data volume in the world. I mean, these are some amazing numbers. Don't ask me what does it mean, zetta. I mean, this is like, I don't know how many order of magnitude increase from mega and tera and then zetta, Amazing, I mean, just mind-boggling. Worldwide revenue of the IT and communications industries actually reached in 2014 4.1 trillion euro. And here is the revenue from the apps that is actually driving from the data applications is about $72 billion. So all these numbers are actually giving us kind of an insight and the motivation to drive our business towards this digitalization, essentially. So today I'm going to talk about two things to share our thoughts on two of that digitalization, actually. I think digitalization focus thing. One is this big data analytics. How many of you have heard this term, big data? Maybe you all know this right here. Okay. So I'm going to talk about what does it mean, big data analytics, for buildings and infrastructure and smart cities, smart campuses, so on and so forth. And then the second one I'm going to talk about is this IoT, connectivity and Internet of Things. How many of you have heard that? Many of you, I'm sure. So what is the definition of IoT? The IoT says that it's a device, and I'm taking the definition from a company or an organization called Gartner. It's a consulting company like McKinsey, but basically in the IT world. So their definition is that you have to, this is a physical device, and that has embedded sensors. Three functionalities, I should say, four functionalities. It has embedded sensors. Number two is connectivity, wireless connections, hopefully. The third is intelligent processing, and then efficient power management. So it can be actually, hopefully in one day, harvesting power from light, or as I'm speaking, harvesting from this acoustic wave that I'm creating using my own energy, right? And then it doesn't need any electrical power. So it could be actually sprinkled, let's say, in this room, and then you do not need to think about how it's going to be configured through your laptop. It will basically be self-configuring, self-healing, and all those self-type things will be applied to that IoT world. Yeah, so that's what I'm going to talk about. But this slide basically shows that those technologies, big data analytics, I don't know, I'm not getting the laser. Okay, the cloud, the mobile and collaboration, the IoT, they are essentially going to permeate in our daily business of operation, maintenance, and service, design and engineering that we do on a daily basis. We still have to design a building, control systems. We still have to maintain them. We still have to operate them for you or by you. But how those technologies can actually help in doing those things, that is kind of our focus. But ultimately, we have to make money, but make sure while we make money, we satisfy your need, we satisfy the market's need. Okay, so this is the digitalization world of Siemens, all right? So we have virtual world on one hand, we have analytics, fault recovery, neural net, this is artificial intelligence, traffic management, digital factory. All these things are this digital world, the virtual world, and this is our physical world that we are in today. So we have buildings, we have trains, we have medical imaging equipment, we have tons of things, refineries, process automation, many, many different things. You know, coal, gas liquefaction plant, many, many different devices, processes, systems, plants that we are physically present, and we want to actually connect this physical world into this virtual world. So again, accessing data and then processing that data, monetizing for the customer's need and the market needs. And this is the digitalization at Siemens Building Technologies, meaning our division, specific to buildings, essentially. So this is very basic, what we do today. You know this, not 27, I missed that. It's 24/7 operation, remote monitoring, alarm management. This is what we do today. Very basic things that we do today. We are now offering new types of offerings for detection and diagnostics, remote services, web-based solutions, continuous monitoring, and this is our tomorrow's vision, basically. IoT, big data analytics, performance analytics, and those things, right? So that's kind of our roadmap as we are going from basic to advanced. So today, we are in 50,000 buildings worldwide, 35,000 million square feet of data that we have. And we have a new cloud platform offering that actually serves 2,500 plus customers. So we are essentially moving from this physical, we are keeping the physical world as is, but now we are migrating also or expanding that physical world into this virtual world. Okay, so this is our goal. The past was focused on integration, as you all know. And we wanted to give this basic kind of functionalities in the building, comfort, safety, and security. Today, we are actually making sure that the building has data and connectivity, and the future will be intelligent buildings. So that's kind of our roadmap in terms of the data and the long-term vision. Any questions so far? Any comments?
What is your quantifier for intelligent buildings as opposed to today? I mean, they're already going off the term that buildings are out there that are considered to be intelligent buildings. So how much further are you taking that?
Yeah, I think hold on to that thought for a minute, and then I'll come back to you. Okay. After I show you a couple of slides with the smart building, and then I'll come back to you. So this is just a slide that shows that today, right now, we have a pretty good innovative portfolio on the fire security, fire safety, security, comfort, energy efficiency, all these different businesses that we do. Our new kind of platform is Desigo. It essentially, probably you have heard about Desigo a lot, so I'm going to talk about this. So that's kind of our platform to essentially create more innovative products in the future, essentially. So basically, again, data integration and then developing new kind of applications. All right, and then some of the things that we are also doing, maybe you have heard, maybe you have not. We have a very sophisticated, advanced demand flow for chilled water system optimization that essentially optimizes your plant, the chiller plant. We have tons of experience in that. In that regard, we have 225 installations worldwide. We can achieve kilowatt per ton as low as 0.33. So this is a pretty nifty, advanced optimization method that we have today.
That's plant?
That's a plant optimization, or chiller plant optimization, yes. And then myself, I am actually launching this new demand flow optimization for variable air volume system on the pressure side, static pressure optimization. We'll be the first one to introduce, this is actually happening today as we speak, the first model predictive fan pressure optimization. And I'm going to talk about at the end, and I'll be talking about this collaboration potential that you might be interested with that application. And it can actually achieve fan energy savings anywhere between 20, actually it's 30 to 50%. So pretty good savings energy-wise. And then of course I said also the cloud platform that we have right now, it's called Advantage Navigator. We have 2,500 plus customers worldwide. And that's kind of our platform to do all this analytics today as well as in the future. So that's kind of our goal. All right, so we will jump into the first technology discussion, and that is IoT. And I have a sample of IoT actually in my pocket. So as you go along, as you kind of pass this thing, this has a, actually, this is, you don't see much because this is very micro scale. But just to give you an idea, this device has 5 sensors: temperature, RH, CO2, CO, and ammonia. 5 sensors. It has wireless communication, so it can communicate wirelessly, peer-to-peer or in a network, peer to another high-level network. And it has also intelligent processing. So you do not need to deal with anymore those analog digital conversion. It will give you the results in degrees Fahrenheit or centigrade or ppm. And then what else it has? It has very efficient power management. So it still uses battery, but we are managing that power very efficiently, so it can have long life. So I'm going to give you, and I'm going to give you a little bit of history. So what is IoT? As I said at the beginning, so the IoT stands for Internet of Things, and this is a vision that actually came from this magazine, German magazine called Der Spiegel. Spiegel, probably you have heard about this. So they basically painted a picture of how this IoT will change the smart city. So the garbage collector basically used this IoT technology. The garbage dumpster basically, right? They will tell the city that, hey, I'm filling up. Or maybe the smell is so bad that although I'm only this much filled, but you need to come and pick me up. So all kind of intelligence could be in the garbage dumpster in downtown Chicago. So as a tourist, when they come, they will not have any sort of problem with the garbage collection issues or any environmental pollution issues, just to give an example. So, just an idea that this will actually permeate throughout the whole city. Building will be having thousands and thousands of sensors, not just one temperature sensor on the wall anymore, right? So those days will be gone. And for that reason, we have to make sure that the cost of deploying, installing these IoT devices is very insignificant, right? So we can create more value actually in that way. So some of the functionalities, it has to be pervasive, ubiquitous, low cost, edge computing connectivity. Now edge computing is very interesting. So the idea of edge computing is that that IoT device, if it has some intelligence built in, some processing capability, then it can actually take some action locally, right there. It doesn't have to send the data back to cloud and then come back from cloud. That's too much traffic, right? So things that you can do locally, you should be able to do it right there. And things can be done in an integrated way with other data, let's say for cities traffic management. Yeah, that's good for the cloud. So we have to really do this both edge computing and cloud computing. Okay, so for building, that device can actually be created to create, let's say, an equipment IoT network, right? So it can actually basically kind of measure the crack in the envelope, the glass, before actually the glass, as we all know, sometimes it happens in downtown Chicago, the glass actually fall on the pedestrian's head, I mean, unfortunately, and people may even die. So we can actually prevent that from happening by having a little sensor, and this is a very macro scale actually that I'm showing you. The actual sensor is at a nano scale or at a micro scale or micro scale, you know. So that can happen with this equipment IoT network. The same sensor now, and I'm showing you to show you a little bit, can change and say, okay, now we need to deploy a comfort and health IoT network, meaning I'm now measuring people's health, you know, environmental conditions and those kind of things. The same platform can then now be deployed for your occupants IoT network, your light, sound, RH, temperature, and all these things can be actually integrated into a simple device. And we can then distribute throughout the building, throughout the campus, anywhere, everywhere, anytime, every time. That's the goal. Very, very cost effectively. Even the landscape, you know, so you can have in the landscape. And as I said, it can happen that the processing can happen locally, or it can also have in the cloud. So in both ways. So the basic idea is the building that thinks, acts, and knows the need of its occupants and the systems and optimizes resources. So for example, today you came in, it didn't have any idea about your preferences, right? So you are basically relying upon all of you, myself included, based on this little thermostat, one single temperature sensor. And this like change. Your mobile phone can have an app and have an IoT. So it basically measures your preferences, your little microclimate, and sends that data to cloud and says, hey, I need to bump up a little bit temperature or lower the temperature or have more airflow. So all these kinds of things can happen if we have a cost-effective IoT platform. Any questions?
I had one. So is it sensing room temperature, or I'm sorry, the people in the room?
Both.
Oh.
Yes, both. So we can have tons of, rather than having one, if the cost is right, you know, if it costs only a couple of dollars, right, you don't mind to say, I want to have there, I want to have here, I want to have next to, you know, Osman's head. So I want to actually measure different places, and the question is, then what you're going to do about it, right? So there are a lot of thoughts in that direction also, and I'm going to show a little bit on that idea. What you're going to do now after you have all this, let's say, data, especially in a collaborative environment or in a place where you have many, many people gathering at the same time, you know, what you can do. So just hold on to that thoughts. Okay, so the IoT for buildings, this whole idea came to us long time this word IoT was invented. We started working on this whole concept, believe me or not, as early as 1997. And what inspired us actually is us, the human species, the most intelligent species that you can find on the planet so far, right? So because this is actually IoT, if you think about a human being, we have sensing, 39 sensors basically, our skin is a platform for sensors, right? I put pressure, it has pressure sensor. If I put a little bit of hot, coffee, it has not a temperature sensor, but a cold or hot sensor, basically, right? So the whole body is thousands and thousands of sensors, basically looking into different kind of environmental conditions. Intelligent processing, of course. We have the best intelligent processor in our brain, right? Fantastic. Multitasking, by the way. Even it does computing when you are sleeping, right? We all know this. Wireless communication. I do not need any wire, right? I'm communicating to you wirelessly. And we have fantastic energy management, right? The food that I take, the water that I drink, I basically convert that into energy so that I can basically talk to you for next an hour or so. So why not we take, and this is the first example of learning from nature that we thought would be very interesting for us. So long before the industry, the world started thinking about IoT, we actually invented this whole concept, and we have tons of patents on these applications for buildings. And that concept led us to actually develop, prototype that sensor that I showed you with our technology partner. And that company, by the way, is in Freiburg, Germany. So they are a fab company. So they are our technology partner for Siemens. Okay, so our idea is then you take all those functionalities that I mentioned before, multi-area sensing, intelligent processing, wireless communication, efficient energy management, and then you converge them into a single chip. And why that single chip? Because the manufacturing cost of a semiconductor chip is almost zero, right? We know this. If you have the right volume, if you have the volume in millions, billions, the cost is nothing. I mean, your toy, how many sensors you have in a toy? Or a little chip in your toy that you buy from, Toys R Us or Walmart, right? Thousands, maybe hundreds. Okay, your car has maybe 1,000 sensors. All are basically using that technology called MEMS, micro electromechanical systems. So we thought that we can actually use this and then make it in a single chip. There are a lot of functionalities, a lot of features. The bottom line is this is good for environment, good for sustainability, and this can give you a lot of efficiency. All right, so our idea was that we shall keep those function blocks, the intelligent processing, the wireless communication, the power management intact, no change. And I changed the suite, the 5-sensor suite, from comfort, then I go to protection, chemical, biological, fire, smoke, flame. I can go to security. I can go into performance. So that way I can increase the volume and bring the cost down. Have we achieved that efficiency yet? No. The answer is no. But we are pretty close. We have the prototype. Now we are thinking about how we can actually create a business model so we can actually leverage on this technology, increase the volume, so we can actually go into the production essentially. So any questions so far?
Have you been to Freiburg, which is a smart city?
Yes, I have been to many times when I was working on this project a few years ago. Yes, a beautiful city. Yeah, it's lovely. It's a lovely. I think it's in Bavaria, right? Yeah, so it's a good city, wonderful city. Okay, so IoT. Any questions in general, I guess, before I jump into IoT? Okay. All right. So now I'm going to talk about. So the one question is that once you have this data, this massive data, billions and billions of data coming to you, what do you do? And here comes the question, answer actually. You have to have completely a different kind of analytics platform that can actually take the data and then process it and then give you some meaningful solutions for your building efficiency, building performance, and so on and so forth, right? So this whole question of big data analytics comes into play because now we can generate data, thousands and not thousands, trillions of data. Now, the financial world and the retail industry, they have been actually pioneers in this field. You know, Target and Walmart, they have actually kind of optimized the use of platform, this big data analytics platform for their businesses. But let me give you a couple of examples to show you that big data analytics also can create some problems. So 2 stories. Target. This is the story 2012 actually, published by Forbes magazine. This is in Minnesota, someplace in Minnesota. This teenage girl was pregnant, and his father or her father didn't know. Yeah. So the Target started sending a lot of materials that you usually send to a pregnant, woman, a mother, expecting mother, without knowing that this girl is actually a teenager. Target didn't know. And father started, opening the mailbox and finding these things and asking his wife question, who is pregnant? Who is pregnant in my family? And when he found out that his daughter is pregnant, he actually sued Target. He said, you have breached my family's privacy, you have invaded my family life, and all those kind of things. The reason Target came to know that, or predicted actually, that this customer is pregnant because of the shopping habits. This, not the teenage girl, but everybody knew actually in their family, except the father. So the sisters and the mother, they used to go and buy things for their daughter. And from that shopping habit, the pattern of what they're buying, Target predicted using this big data analytics platform that this must be an expectant mother. So I'm going to sell her promotional things that she needs when the baby is born. No bad intention, right? I mean, this is good. But unfortunately, incidentally, I should say, the father didn't know anything of this. So this is the pitfall of the big data analytics. You have to be careful, how you apply this big data analytics. But the power is there, tremendous power is there. I thought this might be an interesting story to share with you. The second story is very interesting. CDC spends, and I have a bunch of other examples later on, but CDC spends millions of dollars in this country to predict where is the breakout of some, what you call those diseases, like maybe, I should not say, heart disease. They were actually looking into heart disease, right? And then Pennsylvania, University of Pennsylvania, they actually just looking into the tweets in that area, how people are tweeting. And based on their type of tweeting or tweeted messages, they were actually able to predict where is the heart disease happening, because there was an unusual trend here in this part of Pennsylvania. So CDC spent traditional, conventional method of understanding, identifying, assessing the breakout, unusual pattern of heart disease in one part of the country, and the University of Pennsylvania spent little amount of money. They've only looked at the tweeted messages, how people are tweeting to each other, and from that tweeted messages, big data, right, they were able to predict the same thing. And that's a beautiful example of this big data analytics when it is applied correctly. So, move on. What is big data? That comes from IBM, by the way. This is, I'm not Siemens, but IBM, I must acknowledge that. This is the definition of big data. Volume, big volume, zettabytes, all right, number one. Velocity, speed, quick. So if you think about building systems, you have tremendous speed of data that we actually collect, right? Control boxes, temperature sensors, and those kind of things. Variety of data. So now we are thinking we should not look into the building automation data only, but in your college's business data. When did you change filter? When did you change maintenance services? How many students you have in a building? What students are taking? How students are coming into the classes? Will that extra information, if I couple with the building data, can I find something new inside that is actually not obvious from your building data? And then the last thing is veracity, the uncertainty of data. This is actually good for analytics. So the statisticians, the data analysts, they love this uncertainty. The more uncertain the data is, that is actually not bad, yeah? All right, so that's the definition of the big data. Now, let's look at how Siemens is applying the big data in our day-to-day operation. And I chose this platform, this domain actually, which is the infrastructure, the cities, the buildings, the trains, and everything there. So this is what are the challenges we have today. More traffic, more fluctuating power, especially in the emerging countries, the emerging world. They do not have power, so they're looking for power. Rising energy cost. Fluctuating power is not only an emerging world problem, this is a problem in California, in the West Coast, right? Not only energy, but also something else, water, right? So if we have the data, then hopefully we can solve those problems from Siemens solutions or from other solutions. So solutions is that we are actually solving the traffic in the street of Jerusalem. We are solving future grids, virtual power, and all this kind of thing. I just wanted to give you some kind of vision where we are going. The main thing is that it used to be Siemens was focused on engineering solutions. We are traditionally a heavy, good, solid engineering company. That's what we are known for in the world. But now we are combining data. Engineering, solid engineering is not good enough. We have to have that data that can actually enhance our engineering solutions. So that is the story of this slide actually. I wanted to kind of show you. Smart and cool, so yeah, we have in Taipei, the capital of Taiwan, this beautiful building, 101, I believe, Taipei. This is one of the tallest skyscraper in the world that is also happens to be a LEED platinum building. Yeah, so we are actually saving a bunch of things, but the reason we are saving a bunch of money and making their cooling system smart, because we are not just doing building automation, we are integrating data. That's the whole story in this slide. Okay, so Siemens loves this kind of future vision, future picture, what we call picture of the future. So this is 2060, a city in Africa, all right? So this gentleman from his central command center, he is getting data from his infrastructure, bridges, from traffic jam, from power plants, breakout of power throughout his city. And then he is deploying drones actually, right? He is commanding drones that you go there and solve these problems. This is the vision of Siemens because of a lot of technologies, a lot of engineering, yes, but mainly because data. So again, the message here is that we have to think about data in the future. What data you have in your campuses, in your colleges, that could be used not only for your day-to-day operation, but also hopefully in the future can give you more insights. So today we are doing this. This is our today's world. We have sensors, metering data from utility companies. You may have energy meters also, third party. We are bringing them, then you have structured programming. You sometimes have physics-based modeling, heuristic, statistical. All these things are based on your observed data that you can get from one plant, one air handling unit, one chiller, one at a time. Okay? So moving ahead then, now we are thinking about the occupants, the citizens, the business, city, plant, utilities. All these things can give you much more data, and I'm showing you here is city as an example, but it could be big campus also. It could be big enterprise, like McDonald's, for example. And then the data has many more variety, as I said before. And now you can apply different kinds of things. You can think about the analytics. how our brain actually do the prediction, right? Forecasting, what they call the machine analytics. So machine mimicking the human intelligence. That kind of analytics that we have to do for that data, for that heavy data. And then we can basically discover from learning, identify patterns and all these kind of things. And you may say, so what, right? Okay, so there are some examples. So before I show the examples, I just wanted to say, this is our vision of the next generation machine learning and big data analytics platform. So what does it mean is that we want to mimic the human intelligence. This is already happening by Walmart, by Target, they're doing it, financial world. So when you apply for your credit card, guess what? They're applying this analytics platform to qualify you or not to qualify you based on the big data. They look at your profile, they look at your background, they look at your application and say, hey, how am I going to compare this application with, let's say, 10 million applications of your types of people? And then decide in a flick of a second, yes, your credit card application is approved or your mortgage is approved. They use this human intelligence. Stock market exchange prediction, discovering cancer, by the way. They are using machine learning platform. They have taken the image of the cancer cell and they have actually taken thousands and millions of cancer cell images, not CDC, I'm sorry, NIH, and they have actually created a data bank. So when a new cell comes, they actually compare the new cell with those patterns of the cancer cells and identify quickly, is this a possibility? What is the probability? 5%, 10%, you are okay. That's good, thank God. If it is not, then of course they can start the treatment. So all these things are happening in other industries rapidly. So we are now thinking how we can actually do this kind of machine learning and big data analytics for the building industry, for energy industry, for our industry. And basically we are looking into three types of things. Clustering, I'll give you an example. So this is a very basic differentiation from good data to bad data. Some good students, you know this, people who are teaching every day, they look at good students and bad students, right? Very simple. Somebody, in one family you may have one person that may not be really conforming to the family's tradition and values and those things, right? Can we find those kind of air handling unit also if I look at 10,000 air handling units? Not just by one single one? Yes, of course. The second one is I can actually look at this cascaded learning, right? So I can start from the energy. Let's say I can look at your campus energy and say, okay, let me drill down from that energy picture and maybe I can find some sensor problem actually in a building. The ability to pinpoint a problem from large data. That is this one. And then the last one is most interesting and most challenging. And that is this predictive analytics. Prediction and prognosis. No more detection and diagnostics. That is too late. So based on the previous pattern of failure of a machine, not just one machine, but 10,000 machines, can I predict just by looking at the signal from this machine that this machine shall fail next year, June 21st? Yeah, I may be wrong by plus minus 1 month. But if I take the action today, I can save a bunch of money for you tomorrow. And more importantly, the classroom problem and those kind of things, right? So that is the last one, the predictive analytics. Most interesting, but people are doing it. I have some examples to show. So let me show you some examples here. Oh, one more slide and then I'll jump into it. So from the technology point of view, the data can come from IoT, from sensors. Then you need to have a processor to convert the data from data to information, and then from information to knowledge, and then knowledge to actual services, solutions. So that is your stream, data stream, how the data can be converted into some, just a signal into something very nice, solutions or services. So this is our goal. We are working on this platform deployment right now with one of the major cities in the USA, right now as we speak. And our goal is to actually create that stream. So the raw data comes from IoT, from BMS and other systems. we'll be having a data management platform, then we'll be having a machine learning platform, and then we deploy in the businesses, basically. So the data essentially creates the result, the solutions, after going through this analytics, and then create some nice solutions. And there we can then identify which buildings are not good and which buildings are really, really good. And in this case, I chose all the buildings in New York are not really good, they are bad, and all the buildings in Chicago are good. Anybody from New York? Oh, I'm sorry about that.
Close by.
When I go. All right.
Certainly agree, right?
Okay, any questions before I show the examples? Okay, so this is the first example. Many data from 50 buildings. We fed into weather data, age, type, location. This is just a clustering, no learning, just clustering technique. So you just feed lots of data, and the clustering methods, the statistical method can actually say, hey, my chillers and this company, this organization bought the same type of chillers for California and Minnesota and Montreal and Quebec. Wrong decision, right? All chillers are not made for all climates, right? We know this, but the data now tells that. If you look at the hot climate, they are doing really well. Cold climate, they are not doing so well. But the data should tell us this kind of insights. I don't know whether I have I don't have that example. So I have another example actually, the performance of student in the class with the bad air quality. We all know this. This is fact. Industry has done tons of research on this. If the indoor air quality is bad, then the performance of the students actually, it basically impacts negatively, right? And we have found the examples of that. So you feed the data with the student's GPA, and the data tells you a story. So it is easier for you to go to the president of your college and say, I need money to improve my IAQ. Come on. This is actually impacting our clients, the students, their health, and not only that, but their performance also in the class. So the data can actually give you this kind of insights. This is happening today. Chicago, city of Chicago, by the way. They have 15,000 restaurants, and then only 36 city inspectors. Not good. They cannot inspect all the restaurants, right? So they teamed up with a company you all know, Allstate, an insurance company. So Allstate is actually helping them to identify by what methods, by what analytics, the restaurant can be pre-selected for inspection based on their prior behavior. They sell too many alcohols and too many things and too many this and that. So they're looking into not only the data, but also other things and saying, oh, 36 inspectors, so I should target maybe 100 this month because I know that they may be violators actually using this data analytics tool.
Isn't it true that largely profit centers are more likely to embrace this kind of technology than cost centers?
Yeah,
I mean that's one of our big battles, even with energy savings.
Right,
It's
exactly.
because it's a cost center. Oh, I don't want to invest in a cost center.
Yeah, right. Yeah, I mean, if you can relate that to show that how you can make more money. And the money actually is not really only in monetary sense, meaning that the profit can be that you are retaining your students, folks, or you are increasing that. So you have to kind of equate the value of your service from the data into your business essentially, right? You have to make one-to-one relationship. That's the key. Yeah, exactly. So they are actually increasing, they are shortening the time by which they can actually pinpoint the violators. They're improving the quality of restaurants in the city with the same amount of resources. So it's again the bottom line, right? So this is good. All right. This is fantastic. This is wonderful. City of Chicago, you all know that we have a huge problem in some parts of the city with deadly violence, crime. right? Okay. And I'm just going to tell you the story, don't look at the slides. So Yale professors took the data from city of Chicago and say, hey, if you live in North Side, the city of Chicago tells in a big display, if you go to their website, they say, hey, this is a safe zone, green, this is red.
The Cubs fans are safe.
Right, okay, Cubs fans are safe, right. Okay.
White Sox fans are in trouble.
Right, right. So the point city is making, you are welcome to come, this neighborhood is safe and you have to be careful. So Yale researchers said that, okay, I'm going to look into this data. And they found out a wonderful story. By the way, I heard this story from NPR, National Public Radio. So if you hear NPR, they have a section, they have a news clip, you know, I don't know exactly which day. If you go to their website, you will find this kind of story. It's very nice, actually. So the story is, the Yale researchers, they have found that it doesn't matter about your safety where you live in the city, whether you live here or here. It doesn't matter. It matters whom you know, with whom you actually hang out, with whom you actually spend time. That determines what are the chances of you getting shot or not. Common sense, right? But the data tells you that story. Beautiful story. And there are thousands of stories like this. These are all application of data analytics in the social science field that we want to now embrace and ask ourselves what we can do for the building industry. So this is very powerful.
So don't hang out with disgruntled White Sox.
Exactly. or with the, I'm a White Sox fan, by the way. And this is another good story. This is beautiful. Louisville, who is from Louisville or from Kentucky? Anybody from Kentucky?
There you go, Marty.
Okay.
You say Kentucky?
Yeah, Kentucky. So Louisville, they have one of the worst asthma problem in the nation, believe me or not, right? So they have actually distributed an inhaler with collaboration with a company, pharmaceutical company. And whenever you take this shots, the information actually goes to a cloud from the inhaling device. How many shots you are taking, where you are located, what kind of asthma problem you have, all this information. And by taking this data by the city of Louisville at their cloud, they can then pinpoint and predict where you should not go next Monday or next Sunday, right? So that is the beauty of data analytics that we like to have with you. And how much time we get?
Till noon.
Till noon.
Yeah.
Thank you. Okay. Any questions so far? Any questions so far? Yes, sir.
Well, all of this is a tremendous invasion of privacy issue.
Yes.
And I'm sure some restaurant organization is going to get together and say, this is not due process, this is some kind of profiling.
Absolutely, yes.
So
But I think
this is going to get really complicated.
You are right. But as this gentleman said, that as long as you can show that there is a tangible benefit, you are actually improving the quality of life of those asthma sufferers, they are not really afraid to give you the data because it is helping you. So you have to make sure that number one, you are not breaching any privacy. You are not really saying who it is by name or anything like that.
It's an ethical behavior.
Yeah, it's a behavior. It's an object A, subject A, right? In the cloud. Who has this profile without knowing that my name is here and my name is there, right? And I have to kind of make that kind of separation, basically.
I can see the lawyers salivating over all these, you know?
Yeah,
Well, this is an American kind of issue, though, because
you are right. You are right. But I think as long as you can show the benefits, as long as you can show that you are taking steps not to really vet privacy or sell your privacy or all these things.
I mean, if you watched, I've done a few weeks ago now, there was, I think it was on 60 Minutes about smart guns. Just putting a a smart device on a gun so you knew where the gun was.
Right.
And I mean, the NRA just went ballistic over that whole idea, you know?
That was Smith and Wesson, wasn't it, that wanted to do that? That's in my town.
Okay, so any other question before I get into the last section, and then I have that, I am interested about that collaboration actually, so I want to move fast. Any questions so far? Okay, so if, I'm sorry.
Smith and Wesson, you statement
whether you were
grabbing
or a gun or someone
building
else.
automation, performance, and energy management from Vulture Analytics, looks like it's going to be more or less behavior modification, and not so much with, we do with energy.
That is true,
Yeah.
that is true. I mean, if we do not change, then the buildings will not change. And if the buildings will not change, then nothing will change, right? So we have to start from us, definitely, yeah.
I feel the same way as the gentleman up there, I'm sorry, I can't remember your name, as far as the invasion of privacy, but I also have to wonder the acceptance of the next generation coming on. You know, they may not have the same concerns as what we do. And I get a feeling that this is being built not so much for us, but for what's to come. Is that right?
Yeah, they don't care.
Can you make your comments?
Oh, they don't have any privacy already?
Yeah, maybe, yeah, I can speak.
I mean, big.
Their whole life's on Facebook.
The one I just made?
Yeah, yeah.
Oh, the comment was that, sorry, I was asked to repeat myself, that energy management, building automation systems are not going to be so much about energy management, but more about behavior modification. So that's what big data, you know, and all this analytics is going to bring down.
Right. I agree.
Example? What do you mean, give an example?
Well, I mean, when now you put me on the spot. I wasn't ready for that one. I only gave the explanation, I didn't really give the question.
Same thing, Peter.
When big data says
No, I
stop
think
driving
I
in
give
your
you an
car by
example.
yourself, are you
Maybe
gonna do it?
I can give you an example. You saw that this is actually happening in Germany and some, you know,
They like rules
not
in
on a
Germany.
mass scale, but on a kind of like a prototype or experimental basis. So I know that there is an island next to Vienna in Austria, and they are trying this kind of IoT based. So they will actually penalize you if they find something that you are not supposed to dump in your right bin of your garbage collection process. You have to pay more money.
Right, but they
So-
love rules like that. We vote people out of office that make rules like that.
So next time, think about that in your classroom or in a lunch setting, you know, in the cafeteria. You take and you throw, and if you throw in the wrong place, and you know you, the next time I will penalize. You pay 2 cents more for your next milk of, glass of milk or something like that, right? So I know you're true. If we do not change, then we cannot really change the world around us. That's obvious, right? But the data tells you how to change, where to change, what are the big issues that you can all contribute to, right? So it gives you the new insights that we can take, and that will help us to change basically, right?
I was going to add, in California in particular, we have Aquahawk in certain regions, and you get these notifications because they're metering your water usage to say you're at 90% of your weekly utilization of 4,480 gallons per week. And likewise, even on your cell phones, right, you're getting notice if you're 80% of your data plan. So I guess that's what you're saying in terms of behavior modification. We'll be getting more information through the automated systems to allow us to change behaviors. Like in the sensor we saw yesterday on the wall that would go red if your energy usage is inefficient and green if it's in the efficient mode, right?
Yep.
Well, I think that, and that the information is important. We have 2 utility companies in Delaware. One of them instituted a voluntary load shedding program. In other words, you plug this thing into the wall, a little light comes on, you know, don't do your dishes and curb your energy.
Right.
It's a very successful program.
Yes.
Another company integrated with thermostats and turned people's heat off or down, you know, when the energy use got high. Oh, very unsuccessful program. Americans like choices, but they like the ability to make that choice.
Well, and I think that's where, you know, the behavior modification issue comes in, because we are very difficult, we are so intelligent, we're very difficult
change.
to modify. But I think that, I'll talk to Siemens. I think you're recognizing this, and hence the smart card that, as you enter a building, it turns the lights on only where you can go, and it manages the energy and turns on the air conditioning and the heating only where you're supposed to be, to turn it into a lifestyle for yourself. And I can only, I'll equate it to my hobby. I love riding a bicycle, and it's it took me a while. It took me a couple of years to want to get on my bike, every day. I want to get on my bike every day, but it's a lifestyle modification, and it's something that you have to evolve into. And so I think the management system, or these, the ways that Big Brother, for some of you, I understand perfectly, that they're monitoring you. They're just, encouraging you to change your lifestyle and your habits.
Just one last example, at Valencia, it's sort of like this thing that no one really says it, but we all know it. Like in every room, you have a place where you can adjust your temperature. You only can adjust it maybe 1 or 2 degrees, however, but it doesn't really change it. Like everybody knows that, it's like the joke. Like it's just, it gives you that satisfaction. Oh man, I'm so cold. Let me increase the temperature. But we all know it doesn't really do it, and it's just this unspoken.
Hopefully that will get changed.
I wanted to add on to that, because I was thinking along the same lines, Lanny. Like I could see in the future where instead of having set points on a thermostat, you have your preferred set points in your smartphone.
Right.
And then you can look on Google or something and say, you can go to these areas that are typically set at these temperatures. And if you go to an area where you're changing significantly the preferred, comfort levels there, you might be charged a premium or something like that. I could see
Okay,
that.
with that, I think we need to move on. This is my favorite subject, by the way. So last year, or this year, beginning of January, DOE, Department of Energy, they launched a year-long, very ambitious program to define the building industry 100 years from now. 100 years from now, right? So not just tomorrow. So, and I was privileged to contribute in that whole program as an expert on building systems from Siemens. So I'm going to share some of thoughts that I shared in that whole program of DOE. And this is about built environment sustainability. And I'm going to answer your question now that you had. What is the performance indicators, KPIs with the performance and those things? And I wanted to actually wait till now because it's all about sustainability. Nothing, if we don't sustain, then what's the point of having all these beautiful other technologies, right? If we do not live after 100 years from now because of our own fault, everything else is moot point. Okay, all right, so let's move on. All right, so today, as we all know, buildings are very slick, beautiful facade, lovely to look at, but the energy consumptions, the sustainability issue in general, still remain very, very challenging, as we all know, right? So worldwide, all these facts. I'm not going to go through everything. There is a huge, huge problem that building has created, the building industry has created, knowingly or unknowingly. We are the worst kind of consumer, polluter when it comes to the sustainability and those things. Look at this. 40% material in China is used by buildings. Natural resources, cutting trees, and just move on, right? All right. Health, same thing. Americans spend, average share of time Americans spend indoors where pollutants concentrations can be 2 to 5 times greater than those outside due to ventilation and building materials. Yeah, so this is huge, huge problem that we have created on the energy side, environment side, health side, buildings that we are in, or the building industry that we serve. Okay, so what could be the solutions, I guess? Before we look into the solutions, look at how we started. Many years ago, millions of years ago, we burnt 1 kilogram of wood and created 1.8 kilogram of carbon dioxide. That was the beginning of polluting our beautiful environment, right? Millions of years ago. Not knowing it, unknowingly perhaps. Look at this figure. Rural USA, early ages, 0.1 to 1 ton CO2 per year consumption. All right. Today, my home, 30 tons CO2 per year. Unsustainable. We cannot sustain this. And then New York City, 400 million square foot, 50 pounds carbon, 10 million tons CO2. So what could be the solution? If you look at this graph, this comes from United Nations study, Princeton study, the EPA and all these big organizations, they have been studying this whole issue. So what they are saying is, I take it back, I'm sorry. So if they're saying is that right now we are emitting, try to understand this graph. Okay, so we are basically 8 gigaton carbon per year, all right? If we do not do anything, if we take this path, linear path, not exponential path, by the way, so this is very, very conservative sort of analysis, then we'll be 16 gigaton per year, 2050.
Worldwide?
Worldwide. That is the amount of carbon we are generating. Now, if you want to create this path flat, straight, then you have to remove this amount of carbon from 2008 to 2050, which is about 8 gigaton carbon for next. And that's a tremendous business opportunity, by the way. That's about trillions of dollars business. So all our companies, for-profit companies, now looking into the top line, right? How I can take this challenge, convert that into business opportunity. But now world is saying that this is not enough. We have to actually follow this path. So they said that it's doable, by the way. This is not really hopeless. We still have hope. So they said that if we can look into this 8 gigaton and think about 8 wedges that we have to remove, then buildings can actually impact 2 wedges through energy efficiency, integration of renewable, and the use of biofuels. 3 things. This not comes from Siemens, by the way. This comes from this international organization on environmental control, pollution, done by Princeton also. And each wedge means removal of 25 gigaton of carbon over the next 50 years. So if we do actually energy efficiency, integration of renewable, and use of biofuel. So here is one of your answers. So your building has to have, in my opinion, 3 things. 3 zeros. 0 waste. Then carbon footprint should be, I forgot the number, maybe 2 tons. I think maybe I can give you the number, but very, very low carbon footprint, right? And then all renewable, hopefully. So, you know, what they call, not net zero, it's actually net positive. So you are positively contributing in removing the carbon because of your building. And how you can do that? Well, you can have renewables all over the place. You can actually generate more energy from the renewables than you consume, and then you feed that into your smart grid. So that's your net positive contribution to your energy equation. Then you have 0 waste, 0 water. 3 things. That's your KPI. That's what the world is shooting for, including Siemens, by the way. So let me continue. Siemens says that I'm going to not just have this talk that Siemens is an environmental, company and all this, which we are, but we have said from the very top management that by 2030 we'll be in 100% carbon neutral company. Our own energy consumption from carbon will be completely neutral by 2030. That means whatever we consume, we actually produce more or hopefully the same from the renewable sources. Clear? Okay. And then how we do that? 5 steps. You know, these are the 5 steps that we have. Reduce our fleet emissions, you purchase green energy, we then think about distributed energy systems and drive our energy efficiency programs in our own buildings that we have throughout the world. So that is kind of our corporate mandate. By 2030, this is what we want to achieve. Okay. Carbon neutrality within Siemens. So this is our vision actually. So 2040, and this is someplace East Asian country. All right. So maybe it's in, I don't know, maybe India or in Bangladesh or someplace, and they want to actually achieve countrywide carbon neutrality through 3 things: high voltage direct current distribution. This is interesting. No more AC current. Gone. High voltage DC current. That is where the world is focusing on when it comes to energy transmission. Yeah, why? Because we all know this, that your renewable energy sources, the wind, the solar, what kind of current they produce?
Like DC.
All DC. Right. Yeah. Combined cycle power plants and distributed renewable energy sources. So these are the very, very focused topics that we are pursuing down the stream, long term, so we can actually offer new solutions in that sort of, scope, I guess, for smart cities, smart country, not just cities, but smart region. You take China, for example, you take west coast of USA and say what we can do from Siemens to help you to actually achieve your goal. So these are the big kind of things. Okay. This is a smart building that we are doing today. Oh, sorry. Oh, yes. All right. So this animation shows our solutions today. We are integrating this building with, and by the way, I don't know whether Steve, have you given your stick drives?
After this, we're still loading a couple things on.
So I have actually stick drive this animation, so you can show to your students in the class or to other folks in your colleges. This is what we are doing today. No issue. So we are integrating with wind turbine power plants, solar, electric car, and all those things. Beautiful. Everything is lovely, right? And this is actual animation, so you can play with the time of the day, and it will change.
How do you apply that to a 100-story building where there's no real estate around the building?
Well, I mean, the 100-story building
York
will
City.
be having a lot of what you call, maybe you have some understorage, underground things that you can do, geothermal perhaps, right? You can think about solar in 2 ways. You can have solar heat, you can have solar cool also, absorption cooling. You can have solar electricity also. And then also you can actually integrate that to your solar farm or solar wind. So you have to think about not just the building itself in isolation, but as part of your community of buildings. Right?
So there's some kind of power plants on the side with 3 months?
Yeah, I don't know. These are all Siemens small things. I don't know what they wanted to do here. But my point is, this is what we are doing this, but this is not enough. This is today. This is not future. So what is future?
I think what those things are at the bottom, it's representative of residences and the whole idea of generating energy.
Close to work.
Yeah, net positive
Net
energy
positive.
generation and how that impacts the building.
And a moving
Right.
away from central distribution of energy to decentralized distribution of energy where individual buildings are self-sufficient and they generate their own pieces for what they need.
Right.
Scaring the heck out of Pete, yeah.
That's right. You should be.
Well, yeah.
That's right, 50 years ago.
So, what is the future? The future, I believe that if the future we want to look at, then we have to look at the nature. We have to look at outside and ask ourselves what we can learn from nature to make our building sustainable. And why is that? Because if you ask this question, the nature has been sustaining itself for how many years?
10 years.
Can you? Millions of years, right? Millions and millions and millions and millions of, the answer that we do not know. So learn from the nature, because it is basically sustaining itself for millions of years.
It's a very adaptive process.
It's a very adaptive process. So then we can actually understand what things we can learn that will be applicable to building solutions. And I'm not joking. This beetle in the desert of Namibia is a wonderful example of nature sustaining itself, the life that is. The scientists have been perplexed with this question that how this little beetle can survive in this Namibia that doesn't have any rainfall, absolutely zero rainfall. So the professors from Oxford actually spent years, digging into the hole and looking into this beetle. And they found very interesting thing. They found that this beetle has a velocity sensor, believe me or not. It senses the direction of wind and the way and how strong, should not say velocity, but how strong the wind that is. And it goes up to the mount in the morning in the right posture, so it can have the maximum wind striking on its back. Why back? Because the back has two materials cleverly designed and created. One material is hydrophobic and another material is hydrophilic. So the hydrophilic, which attracts moisture, and in the desert of Namibia, especially in the morning, you have this moist air coming from the coast that goes over this desert only in the morning, that's it, right? So the moisture is attracted by this hydrophilic material on the back. It basically condenses the water. And the hydrophobic says, oh, I do not need this water. So where that water should go? It goes to the mouth. This is how beautifully this whole thing is created. So up in the morning, thousands and millions of Nami beetle goes up in the mount and they drink water just by standing. That's it. So the scientists today are actually thinking that in the future, and this is happening in the labs all over the world, they are creating the glass with this hydrophobic and hydrophilic material combination. So early in the morning, especially in the desert area where you do not have much water, they can actually attract the water and then can basically take that water and they channel through the glasses of the building to goes into the vegetation to actually, in a very cost-effective, efficient way, without spending.
And all the beetles in the area will die of thirst.
Yeah, because
There's plenty of food to share. Okay, so the next one. All right. I think I lost somehow. I'm not getting.
It's not moving?
It's not moving.
Just escape out of it for a second, see if that does anything, 'cause nothing.
Is it?
Technology.
Beetles are
Yeah.
computers.
Let me grab Amanda's.
Osman, as we wait, can I ask a question? And this always bothers me. We talk about AC current and DC current, and we know that it's some ridiculously efficient number of 93% or whatever in terms of from point of origin to end user, in terms of loss of energy where we don't lose anything. What about the AC? Why isn't there an investment in DC current? In terms of, it just seems counterintuitive to me that we haven't already made the investment in moving from AC to DC current. in terms of reduction.
Well, that is the transmission problem.
Transmission problem.
It's a
It's strictly a transmission problem.
That's why Tesla
We have
won
central generation
Right.
distributed over long distance. You can't do that with DC.
long distance is when you
That was the
save more
problem when
money.
they tried DC.
In other words, you
Yeah.
save more money when you use DC current over longer transmission
No,
lines.
AC over long transmission.
Really?
Con Edison started that idea, but they could only distribute like 2 miles from the central plant.
And then the
And
lights would get dimmer and dimmer.
That's why Tesla won over Edison.
China's doing just the opposite.
But if you get superconductors involved, then...
China is doing just the opposite.
Yeah, but at short distances is more efficient.
Short distance.
So if you're producing on site,
All right, so.
Yeah, that's what that
The
was.
answer is very simple. I think we have already spent how many billions of dollars in creating the AC infrastructure, right? So the companies are very, very afraid that, you know, they will be losing actually their investment that they already have made. So this distributed energy systems and this whole idea of DC is happening in that part of the world where they do not have anything right now. So they can start from scratch.
And they're only doing it over short distances.
Yeah, I mean, that's all
They can't do it over long distances.
Right, exactly, and that's the whole point. That if you have this distributed energy systems like microgrid, then you do not need the long distance.
Yeah, there's this whole notion of that they can leapfrog technological
Yes.
intermediate steps that we stumbled around in.
Okay, so this building is actually built in Spain. And this is, so what they have done, they have looked into squid, the skin of squid. And then they basically said, I'm going to actually mimic this building with new materials so I can have all these different functionalities. Transparency, flexibility, kinetic skin, sun umbrella. So this is a real building, and they're essentially saying, I'm going to create my skin that essentially resembles a squid skin. And this is not, you know, this is not really future. And this is another example how you can create a building skin that is very similar to human skin. Why human skin? Because our temperature here is constant, right? So we actually have more blood flow or less blood flow to maintain a constant skin temperature. Beautiful, right? So why can't you do the same thing with the building? So essentially the whole idea of building is that you try to actually block the transmission of heat or energy from outside to inside. You make the intelligent envelope so you don't have to really deal with this problem after you actually allow the heat to come or lose to the environment. That is the whole idea. And then we have created this notorious air conditioning systems that is not good, as we all know. The quality of air is bad to begin with, right? Okay. All right, so here is my favorite. All right, so if you go to this website, JCAP, JCAP, Joint Center for Artificial Photosynthesis, the government is pumping in $40 million every year to create a new chip, and that chip is going to be the same as photosynthesis, artificial photosynthesis. So we invented at Siemens some new applications for building envelope in the future. So what we do is with this photosynthesis chip at the skin of the building, we capture carbon dioxide from atmosphere that is actually polluting our water. We then split the CO2, just like the tree does, and release oxygen back into the atmosphere. Keep the carbon, concentrate, bring the water from the ground, the wastewater from the building, and create biofuel, just like the tree does. So our concept is building as a tree. So this is what we are working on with JCAP, by the way. This is the concept. So inspired by nature, building energy will be actually confined. The system, the building energy system will be not inside the building with your water hydronic or with your air. It will be all played on the skin of the building with nano plumbing So the plumbing engineers have to be nanotechnologists in the future, 100 years from now.
Yeah, I can see the building maintenance guys now.
Right.
Boy, those plumbers are gonna be way
Tiny
smarter
little
than-
guys. Tiny little guys. You won't fit.
Now you see, and this is not really a science fiction. You know, as I said, you know, the U.S. government is pumping into this technology, the research, $40 million every year at Caltech and UC Berkeley, Joint Center for Artificial Photosynthesis. So we are going to be a founding member of that whole industry consortium. We are working on our own also. And the idea is that you produce energy, biofuel, right, from carbon. You solve the environmental problem. You make the environment better by releasing oxygen. Just act like a tree. The tree is beautiful, building is not. So how we can change this? We can make building as beautiful as the tree. Okay. All right. Any questions so far? I have 2 minutes maybe. I can talk about.
Oh, yeah.
Okay. All right. So let's idea for collaboration. This is completely a different thing. So my goal is to pitch to you a new kind of tool that we can actually develop, where you can teach all these different things, maybe at college level, maybe at even higher ed, universities, fluid flow dynamics, duct design, laws of all these things, right? But using real data and in real time and interactive training. And how you can do that? All these things, because we have developed a new type of, and I'm not going to go through all these things, a new type of offering to reduce the pressure in your system, in a fan, VAV fan system, but we do it in a model predictive way. So we create as part of the process, a model of your system. We do some simple test, and then we actually come up with a model of your system, the duct system that is. So what does it mean, model? Model means the pressure and the flow relationship, right? So we can teach the student in real time, and I'm going to skip this. And I have, by the way, all these things in your sorry about that.
All these things are in the file.
In the files, right? And how does it work and everything. Okay. So here is the whole thing. So if you have a duct system, a real duct system, right? If you have a fan, a variable speed drive that you want to modulate to save pressure energy and therefore the fan energy, then we can actually implement a new offering from Siemens. So we will be having a model predictive system, so we lower your pressure in the system. And then in real time, we can show you exactly in each node of the system in your real duct how the pressure and flow are varied. So they can then understand the Bernoulli's principle, how to design the duct, how this fan is performing, all these things in real time. So the basic idea is that we choose a campus VAV air distribution system, we implement this new offering, we develop a classroom teaching training tool with you, we connect tool, then a classroom tool, so you can actually demonstrate as part of your training program also, how to do this kind of application, to this new application, and then you can look at the real-time performance and the real-time learning also. So that is kind of, and I don't have time, otherwise I could have gone in more detail. But if you are interested, then I can have more time with you. I can share, how we can do it, and then who does what, how we can do the funding and those kind of things. So, so the basic idea is that you will be having a real VAV system in your campus that is hooked up with your classroom, tool, and you demonstrate the Bernoulli's principle, the duct design principle, and all those things with real data. That is the basic idea. And then you save energy also. So that's the big incentive, that you save energy, 30 to 50%. If you have a constant static pressure right now, then we implement this whole thing, and then you save money. So it's hopefully a win-win situation. So you don't have to decide right now, but
can it be applied to a DOAS system with a variable speed based on CO2 sensors in all the zones?
Yeah. We are not touching your thermal control strategy or ventilation strategy. All we are saying is that given your CFM set point from your VME boxes, I can lower the pressure so one of the boxes is fully open without measuring anything based on the model. So we are predicting that. So this is completely a brand new stuff. If you look at the ASHRAE handbooks, they mention about this technology. They say this is very stable. You don't have to tune it because you know that trim and respond and those kind of things is a nightmare in terms of tuning those kind of things. So this is completely a brand new offering. So I'll be happy to share more if you're interested, and we can then talk a little bit more on this application.
And you guys can also, if that is intriguing to you, you guys all have my card, and I can kind of serve as a conduit between yourselves and Osman.
Well, the contact, his contact.
Oh, you?
Yeah,
We don't have yours.
Yeah, you do. Yeah, I gave it to everybody.
That must have been.
Oh, you're probably out of the room,
I
Paul.
missed it.
All right, you don't get one.
That's probably when you're in the kitchen.
I'll give you one.
So that's all I had to share with you this morning. I hope you enjoyed it. If you have any questions.